name is Jonas Copén at Dex Group. Some of you met me in the last research mission in Villarreal. Dex collaborates with NACER in the organization of this workshop. In fact, I will be in charge of moderating the session and introducing the lectures this morning. So welcome to this networking workshop entitled Agricultural, Animal Husbandry and Forestry to Face Climate Change, hosted by NACER, the Basque Institute for Agricultural Research and Development in the framework of the CCC project. I would like to remind you that this event was scheduled today in Vitoria, but due to the coronavirus outbreak, it has been finally hosted online. That's live. CCC project is co-financed by the Interreg Atlantic Area Program, and it's focused on the analysis, assessment, and capitalization of the successful European projects on the prevention and management of risks deriving from climate change. Therefore, the main goal of this workshop is to share best practices of the European projects identified that can serve as models for different countries in order to face the challenge of the agricultural and forestry sectors due to climate change. 8 projects from different European programs will be presented in the next 3 hours. All of them will have 15 minutes to share their initiatives with us. We will set aside 5 more minutes for questions from the audience. Please use the chat box to ask questions in real time. The chat box is the balloon just located to the immediate right of the 3 points in the control panel. Now, Carlos Garbizu, as Chief Scientific Officer at NACER, will pronounce some welcome words, and we will try to put into context the purpose of this workshop. Carlos?
Sorry, Carlos. Francois, could you close your camera, please? Thank you.
Okay, yeah?
Yeah, Carlos.
Now I can talk, Jonas? I can talk now?
Yeah.
Okay. Hello, good morning, everyone. It's a great pleasure and honor to welcome you all to this workshop on the interactions, on the links between climate change and agriculture, livestock and forestry. Before we start, let me please introduce very briefly, of course, our institute. At NACER, the Basque Institute of Agricultural Research and Development, we are around 200 people doing research and innovation to improve the competitiveness and the sustainability of the agricultural, livestock and forestry sectors. At NACER, we have 5 different scientific departments. The first 2, the Department of Animal Health and the Department of Animal Production, work together to improve livestock health and production, of course. Then we have the Department of Plant Health and Protection, where we carry out research to optimize agricultural production systems and also to foster ecological agriculture. Then we have the Department of Forest Sciences that aims to have a more productive and more diverse and sustainable forestry in our region, in the Basque Country. And finally, we have the Department of Conservation of Natural Resources, which is focused on reconciling the sustainable use of natural resources with the conservation of the environment. Sorry, Jonas, I cannot hear you. Can you repeat your question, please? I cannot.
Yeah.
Okay.
As far as the climate change is concerned, what do you consider to be the risks arising from climate change that most affect agriculture?
Well, it is quite clear that climate change is a huge challenge for agricultural production. In fact, the extreme events associated with climate change, heat waves, droughts, the alteration of the rain distribution patterns and so on, are already having negative consequences for the growth of agricultural crops and forest plantations. then it is very clear that agricultural practices must be aimed at selecting species and varieties adapted to the new climatic conditions, at controlling erosion, stopping the loss of soil organic matter, at reducing the inputs of fertilizers and pesticides, and so on. But at the same time, I would like to emphasize that climate change is a fantastic opportunity to make the required transition needed by the primary sector towards a more sustainable and competitive model. I do believe that climate change is currently being a driving force for research and innovation in the primary sector. But not only for the primary sector itself, climate change is an opportunity to start walking in the right direction. In a way, climate change is, boosting us to take the challenge to advance towards a more sustainable way of life. Imagine for a second that climate change were not real. Of course it is real, but imagine climate change were a hoax, a joke. The reality is that we should still do the very same things we do when we talk about climate change. When we talk about climate change, we talk about clean energy, renewable energy, energy efficiency. We talk about building resilience for ecosystems and social ecosystems. And for that resilience, we talk about protecting biodiversity. Let's be realistic and not delude ourselves. In a world like ours, with a constantly growing human population and a dramatic rise in our consumption of resources, those concepts of clean energy, renewable energy, energy efficiency, resilience are not an option. They are an imperative. We must go in that direction with or without climate change.
Mm-hmm. And what kind of activities does NACER carry out in terms of mitigation and adaptation to climate change?
Well, NACER has been doing research on climate change for many years, but since we have time limitations, maybe I would just emphasize some activities. For instance, at NACER, we work on the selection of crops and tree species, and also agricultural practices adapted to the new climatic conditions. We also pay special attention to soil health. After all, soil is the basis of food production. And we also study ways to improve the capacity of agricultural and forest soils to store carbon. And we identify management guidelines that promote the mitigation of climate change by means of the sequestration of carbon in the soil. We also quantify the carbon footprint and the water footprint associated with food production. Then, in collaboration with our friends from IOBE, the Basque Environmental Agency, we work on climate change scenarios for the Basque Country, and we make the inventory of greenhouse gases emissions from the Basque primary sector. Also, we study the presence and distribution of pathogen vectors, mosquitoes, ticks, and so on. As you all know, as a consequence of climate change, these pathogen vectors are moving their areas of distribution towards higher latitudes. And in consequence, we are detecting the arrival of new species of pathogen vectors. And well, more or less, that's what we do. It's a summary of all the activities that we do at NACER on climate change.
Okay, thank you. Thank you, Carlos. Thank you for your words, for your introduction of this workshop. We can start with the first presentation. Dr. Jean-Francois Berthomier will present the first project, the CCC project. Dr. Jean-Francois Berthomier is the director of the Climatologic Association of Middle Garonne and Southwest of France. He is also the president of the Cluster of Water and Climate from Agen. Jean-Francois is currently coordinating 3 cooperation projects, ClimaAlert, financed by Interreg Southwest program, and 2 others funded by the Atlantic Area Program, RIS Aquasoil and CCC. Jean-Francois, it's your turn.
Bonjour à tout le monde. I hope you see my presentation. Is it working?
Yes, Jean-Francois, it's all right.
It's all right. Okay. So I'm very proud to be with you without using too much carbon, to be all together talking about a solution for the next decade about climate adaptation. I'm I'm going to talk about this project CCC, Capitalizing Climate Change. It's a project in risk management for a better resilience of our production. I'm working in the Middle Garonne of the southwest of France, there in Agen. And I'm working as a son of a farmer in an association of farmers that is fighting against frost, against droughts, against any scourges from the climate. And after my PhD, I went to Canada where I learned about climate change. It was in 1981. And since that time, I'm trying to push all the farmers around to be more adapted to this change. Being in an association of farmers, we have climatic probes everywhere measuring data. And from this data, since the last 20 years, we are following the number of days when the temperature is higher in Agen, higher than 20 degrees, 25 degrees, 35 degrees, and now 40 degrees. As you can see, in 2003, we had a very dramatic situation. And it killed many people in France and in Europe. And now in the last year, we had almost the same situation, luckily without. So what we believe and what we see is that the climate of Spain, of Catalonia, is coming to our place, and we are not ready. In 2003, the number of people who died during that event were very, very much important. It was higher than it had happened during the COVID the last few months. So a heat wave could kill people, and it may change things about the possibility to force the people to consider the climate change as something very harmful, more harmful than a virus. You know the killing curve showing the progression of CO2 in the atmosphere. It is a measure in different places. And during the COVID period, I was sick myself of the COVID, and I was thinking, at least we have a real situation when something is not working. So we will reduce the amount of CO2 that everyone is providing. And early April, there was a reduction of 15 or almost 20%. And so I hope to see that in that curve, and it did happen. Nothing changed. Some scientists like Richard Betts, near one of our colleagues from WRT, is showing that there is a reduction of 0.32 compared to a progression of 2.4 for the last. So this man says the reduction of emission doesn't immediately reduce concentration. It only slows the rate of increase. But look, the rate of increase was reduced only mildly. So it means just before, the director of NECA said we have to change be more sustainable. But look how our society changed during 2 months, didn't change much. So from what I see is that it is going to be more difficult for the future for example, the sea level rise. The acceleration of the ice melting is going to increase. Luckily, the global oceanic content absorbs most of the energy that cannot be released through the atmosphere by through the CO2 and methane gases. but it's not going to happen for a long time. And the anomalies of temperature for the last years are providing us enough information of what is happening, like in Siberia right now, with warm temperature that are releasing CO2 that is in the permafrost. And of course, what is there already happened in the past, but not so often. So why are we here all together? We are here together because we want to help for reducing the emission of CO2, for finding solution with agriculture to increase, for example, the carbon that we are going to store in the soil. We want to be more resilient to what is happening. Yesterday night, we had a big storm here, luckily only with rain. And we have to adapt to this future that is already present. By working with people in Spain, in Portugal, in England, and in Ireland, and opening what we are doing in the Atlantic area to other places in Europe, we want to see what is done. And that's why I welcome you to present and to explain us your solution for the trees, for the cattle, for the fields. And we want with CCC to understand better what you are doing in your place and how it can be improved or adapt to other places if that is possible. And the idea of CCC is capitalizing on what is already done, but what is not known outside the perimeter of the partners. And so we are going to build a platform, a web platform with these projects that we are interviewing, that we are sometimes meeting through virtual situation. And we hope to help this project to be better known. And then we will write a diagnosis on these projects, and we will try to write a guideline for the next generation of EU cooperation programs dealing with climate change and risk management. So we are interested also in the negative aspects of your project, just to avoid those problems in the future. That's what I wanted to just to introduce today, hoping we will work finally during these 3 hours. And I confirm that today we are not together in Victoria. I regret that because I love Spain, but we have saved about, as Laurence told us yesterday, about 4 tons of CO2 comparing to our first meeting. So merci Necker for hosting this virtual meeting, and good presentation and good work for this morning.
Thank you so much, Jean-Francois. Thank you so much for this really interesting presentation. We can move on to the next presentation, to the next project. Vanessa Sanchez Ortega from the Fundación Global Nature will present the Life Agri-Adapt project co-financed by the LIFE program. Vanessa Sanchez holds a Bachelor of Science in Environmental Science, and she joined Fundación Global Nature in 2002. Since then, he has been involved in different projects related to nature protection, rural development, and agri-food sustainability. She currently coordinates the Life Agri-Adapt project, which objective is to demonstrate how sustainable adaptation measures can help livestock, arable, and permanent crop farms become more climate resilient. She has also coordinated other European projects, such as a Life Plus project local action plan to prevent climate change in Las Rozas de Madrid, Las Rozas por el Clima, and the Interreg project Ecoberger, related to the common agrarian policy and addressed to youth. Thank you, Vanessa, and the stage is set for you.
Thank you, Jonas. Thank you very much, just for inviting us to participate in this project. Can you see my screen now?
Yeah.
Yeah. So can you see my presentation? Oh, 1 minute. It's here. Do you see my presentation?
Yeah, we
Yes,
can.
Vanessa.
Okay, perfect. So thank you very much for inviting us to share with you our results of this live project. It's an AgriAdapt project, and we try to develop a comprehensive response to climate change for European farming systems. And so this project had main objectives or main ideas that were to demonstrate that the three main farming systems, livestock, arable, and permanent crops, can be more climate resilient by implementing sustainable adaptation measures and strategies, and to show how climate change can be an important and powerful driver for the necessary shift towards a more sustainable agriculture, as our previous person was telling us. So this project was developed in the four main climate risk regions of Europe. So we had one partner covering one of these regions. We had in Germany our coordinator, the Lake Constance Foundation, and we had a partner in the Northern Risk region that it was in Estonia, Estonian University of Life Science. We had covering the climate risk region, Atlantic risk region, to Solagro from France, and we covered the Southern risk region in Spain. This project was finished just in April, 2 months ago, and it began in September of 2016 with a big budget as it's a live project. The main methodology of the project was this. First of all, we look at the climate projections. We made some baseline reports regarding climate impacts on agriculture, one baseline report for every climate risk region, and we make first a preliminary catalog of adaptation measures. So with all this information and with the help of our partner in France, the main developing the methodology, we made a common decision supporting tool to assess at pilot. Sorry, I have some problems. Can you see the screen? Because sometimes it goes dark for me. Yeah. So we made this climate change vulnerability assessment at farm level in 120 pilot farms, and we made adaptation action plans for every one of these pilot farms that we monitor and evaluate during the project. And finally, we made these general and sustainable proposals for adaptation per farming system to mainstream and transfer to national, European level and beyond to the authorities. And of course, we made communication and we made some training and also all of those actions. So the final vulnerability assessment for these 120 pilot farms across Europe were based on this methodology that we know that there are 4 major weather events that affect our crops and livestock. And those are temperatures, high or low temperatures, or even water deficit or excess of water. So we have to look at the gene of the plant, so the degree days for the development of the plants. So when we were looking at the data, we looked for real observations for climate data, and we look at the yield compilation. We made yields compilation at every region where we had a pilot farm. And this is an example for France. These are yields for soft wheat in Marne, France. And we had a look at what happened the worst years for yields. In this case, those were 2016 and 2003. So for this case, for this soft wheat, we saw that the main agroclimatic indicators affecting to this crop were hydric stress and thermal stress, as you can see here in this graphic. So from vulnerability to adaptation, we know it's a learning process for farmers, and there are some climatic hazards that we have to face, or farmers have to face, and those are the weather events we have to face at the moment of the year. But then there are the climate trajectories where we have an idea of what's going on thanks to the model and scientific information. So our roadmap for adaptation was that we began in 2017, and many farmers didn't know about their vulnerability. And at the end of the project, they were aware of vulnerability, they identified some solutions, and they knew which efficiency were having these solutions. The common decision tool had these relevant points. In this tool, we have information about crop yields. We have information about climatic data, daily climatic observations for the recent past, and daily climatic projections for the near future. And of course, we had to make some farmer interviews to know the agronomic data on the farms, and some climatic risk scoring that we were doing to know about vulnerability. So climate data we have used during the project are from this portal, AgriForecast, from the Joint Research Center. And here they have information in 25 per 25 kilometers grid points all around Europe. So we can have very accurate information on recent past climate observation and regarding the future projections in 3 scientific models. So with the tool, we can calculate more than 75 agroclimatic indicators, and those are generic indicators, but even for fodder, cereal crops, summer crops, rapeseed, and vineyards and animal indicators for livestock. So these are our pilot farms. We have looked at dairy, arable crops, beef, vineyards, orchards, tomatoes, pork, and sheep, and we have around 126 pilot farms across the 4 countries. So the characteristics of the pilot farms are very diverse. There's a high diversity in farming systems. We have cereal, as I told you before, but even the size of the farms are very diverse too and variable. And almost 75% of the farms are conventional, and 25% were organic. So we made this assessment in these pilot farms, and we had a look at the climate projections, and we could see these agroclimatic indicators in the future. This is an example of one of these indicators, because you can find all our information in our website. But for instance, this is heat stress for cereals in all these regions that we studied, and this is how it's going to be from recent past to the near future. As you can see, this variable that the maximum temperature up to 25 degrees from the 15th of April to the 15th of July is going to increase considerably in all the regions, as you can see in this graphic. And this is affecting the cereals in the moment of the filling of the grain, so it's causing the shriveling of the cereals. And this is another example for livestock for thermal lyric stress. And this is how it's going to be in the 4 countries, from the recent past to the near future, from different categories. And this is an important agroclimatic indicator for livestock. So after that, what we made was a SWOT analysis for the pilot farms. This is an example for the Southern region, and we assessed what was going on in every farm. And so after that, we could make a specific proposal per farming system on sustainable adaptation. But these are general comments on the different agrarian systems we want to tell you. So when we face adaptation to climate change, we must know that there are different issues we must take in mind. That adaptation is, first of all, we have to adapt to a trend in a climate variable. There is a trend of that variable. And, but even we have to reduce the interannual vulnerability. As you know, every climate variable has this variability during different years. But even farmers have to face extreme events. And so we have to focus on that when we develop an adaptation plan or a strategy. And we have to look at different vulnerability components at farm level. For instance, for arable farms, we should have a look at insurance, market, crop system, soil and farming practices, water dependency, and varieties. So our adaptation measures were classified in 3 levels: efficiency in the short term, substitution, and redesign. And for instance, these are the key adaptation measures we identified for arable farms. At crop systems, we know we should adapt the sowing date, the crop diversification and mixed cropping. At soil and farming practices component, we should maximize the soil cover. We should reduce the tillages, and we should improve organic matter content in the soil. Regarding varieties, we should select suitable varieties, limit the area sown by its variety, and set up a mix of varieties at field scale. And in water dependency, we should increase irrigation efficiency. We should substitute some crops depending on the water needs, and we should improve the resource management. And there are some advanced modifications. These are for the very long term, and these are to have a wide and diverse crop rotation, to direct seeding with cover, to go to organic farming, and to have a complete mix of varieties depending on the plot of every farm. So we have made this for the other agrarian systems. You can have a look at it because I will share this presentation for you. Now we don't have time enough to introduce everything, but you should keep in mind that there are 4 key measures that no regret adaptation. Those are diversification, 1, livestock buildings, soil conservation, and extensification. And this works for the 4 regions. And last of all, I would like to introduce you one of our main results. That is the AgriAdapt web tool for adaptation. We try to include this common decision tool in a simple way online, so everyone can get into our website and have a look at this web tool for adaptation. And it has 3 modules. The first of those is an adaptation quiz, which main objective is to aware farmers to know about climate change. So for every climate risk region, there are 30 questions regarding climate change, climate impacts, and adaptation. This is an example of one question. You could choose one solution, and then you will have the explanation of the correct answer, and even a learn more category where you can have more information on that. And the second module is about yield and climate, where we share some observation and projections. And there are about 300 grid points available across Europe, where you can click and go inside of those grid points. And once you click, you will find information about yield compilation until 14 crops for that region concretely, with yield variability from 2000 to 2017. Then you will find concrete information on climate observations for the recent past, with 11 illustrations for average temperature, precipitation, air deficit, frozen days, and estival days. And last, you will find information on climate projections, and you will find in agroclimatic indicators 10 for generalities, 9 for crops, 3 for fodder, 3 for animal, and 4 for vineyards. And the last module is about the sustainable adaptation measures. So you will find these measures classified by climate risk region and classified by this short, mid, or long term, and by components of vulnerability. And you could click to every one of these measures, and you will find these fact sheets on the measure regarding the climate risk region affected, the weather event address, and some other information about sustainability components for every measure we can propose to the farmers. So adaptation is a process for every farmer. And what we have learned is that there are different steps, and farmers first must know what is climate change, what is climate, and then which are the main agroclimatic indicators that affect their crops or their livestock. And then they should know the adaptation measures to can develop an adaptation plan. So the key components we have as a conclusion are, of course, classified in soil management. We think living soils with a high amount of organic matter can absorb and store water, and it's very important to keep in mind this. The nutrient management is very important too. There must be a combination of organic matter with nutritional needs and the soil biota and structure. The water management is very important too, more in the southern risk region. Pest management too, we should focus on integrated pest management. Of course, we must have a look at income and profits, at risks, and we think insurance are important in these new scenarios of climate change. Animal welfare must be, we must focus on that too. and of course on biodiversity, because we think, sorry, that biodiversity is a very important cross-sections element for all the other elements above. And just to close, some remarks, you can find all this information in the in the website, because we have already finished the project and we have published all the information, the manual. There is a training pack too that you can find with presentations. There is the web tool into the website. There are some videos with some case studies. In the manual, you can find some case studies too. There are some news, and that's it. So thanks very much. I don't know if you have any question or whatever. This is for me.
Thanks, Vanessa. Yes, it's time for questions. Gerardo Vesca at Naker will be the person in charge of managing the questions from the audience. Gerardo?
Yes. Yes, I am here. Thank you, Vanessa, for your presentation. As Jonas was mentioning, I will be in charge of collecting the questions from the chat of the meeting and transferring the questions to the speakers. So you are the first one, and thank you for your presentation again. And I have one question from Jean-Francois Bertomeu. I have two questions, as a matter of fact. One of those is, are your conclusions have given to the CAP negotiators?
Yeah.
We know, yes. Okay.
Yeah. Well, every partner has been working in their country at national level to try to make some policy incidents. And I can tell you about Spain. I think Solagro and Lake Coastal Foundation and our Estonian partner are doing that work too. But for instance, in Spain, we have participated in all the process for the CAP reform. You know, every country is doing a strategic plan for the next the post-CAP reform. So we have participated on that, and we have tried to transfer all our results to try to make this new pack more sustainable. And we have tried to include our results too in the new eco schemes and so on. So yes, the answer is yes.
Okay, those are good news, because you have developed a lot of interesting practices for farmers. So it would be nice to have those taken into the CAP new version for the next years. Jean-Francois has posted another question that I am going to translate it to you, to pass it to you, but let's see if I can understand, because I am not very sure about the question. He says, replacing corn by sorghum did not work. How to make it working in the future? Yes, you know, corn and sorghum. Sorghum, I guess, is supposed to be a more drought-resistant crop in comparison to corn. And he says that for what he knows, it hasn't worked. So
yeah, this is a result for more accurate. I mean, more. Sorry, it's more. I know our partners in France have tried this with the pilot farms, but I'm not very sure on how it works, because in Spain, of course, in Spain it's not working to replace corn by sorghum. But I know they have tried it in France. Our partners Solagro, they work in the region of Toulouse. And I think they have many pilot farms. Maybe you can find more information in our manual. I'm sorry I cannot answer to your doubt, but you can keep in touch with our partner in France, and I think they will tell you the results they could find on that.
Okay, thank you, Vanessa. We have another question from Maria from the Basque Country. How was your experience with the farmers? Was it easy? Was it difficult?
Well, it depends. Yeah. In Spain, for instance, it was very easy because before of this project, Adapt, we made another project regarding mitigation to climate change. It was another live climate change project, and it was the same methodology to work with pilot farms to find action plans to mitigate climate change. And it was from 2010 to 2013. In that time, it was difficult to find farmers to participate in the project. And when they were participating, even if the action plans were meaning some saving of money for farmers, because as you know, mitigation is to save energy, so it was saving. It was difficult for us to get them to implement the measures. But by the against of this, in this AgriAdapt project, what we saw is that when we began to look for farmers, for pilot farms, we were very successful. I mean, all the farmers wanted to participate because they already have the problem, at least in Spain, in the southern region. They are already facing many climatic events, as you know, and climate change here, and southern region is going to be one of the worst regions in the world. So they were participating very actively in the project. And by the first time, we had some cases where farmers were calling us to send them the reports of the project with the projections and the indicators and the solutions and so on. So yes, they are at least in Spain, they are very aware. And what we have seen is that as we are suffering climate change before than in the rest of the regions of Europe, what we see is, and because Mediterranean region is already has already climate very variable, because it's like that, in comparison with another climatic regions as Atlantic or continental that are more stable in the time. So our farmers are like, how can I tell you, they are like more prepared to face the climatic extreme events, because they already have deal with droughts, with heat waves and so on in their past. So, but when we went to visit some other pilot farms in the meetings, international meetings of the project, that we used to visit some pilot farms from our partners, what we saw is that, for instance, farmers in France are not so prepared, because it's getting something new for them, that these extreme events are getting are happening more often. I don't know if I explain myself, but it's my point of view. Of course, it's some sensation for me in the project. But yes, I think farmers are very aware, and they need solutions to adapt to climate change. And in our experience, they are getting the results of the project and applying all the action plans we propose them. But even this is not, this is not like I give them an action plan with some measures and that's it. This is like a process. I mean, this is like a strategy for future. They cannot deal with some measures in the short term, but they know they will have to begin to change things year by year, because climate is getting worse and worse. I don't know if I explained.
Yes. Yes, it was very clear, the answer. I understand that the farmers who are more affected by climatic conditions are more prone to take advantage of the proposed solutions. Yeah. We have another question for you, Vanessa, again from Jean-Francois. Do farmers, I guess, in the drought regions or more climate-affected regions ask for more water to be stored, or for more water to be supplied to them for irrigation?
Yeah, well, in Spain at least, water is our talón de Achilles. I don't know how to translate that in English, sorry. I mean, water is going to be our main problem in the southern region. And what we have seen is that many farms or crop systems will need a deficit hydric at least to ensure the yields in the near future. And we don't know if we will be able to have water enough for that. I mean, even if some farms are rain-fed, they will need deficit hydric in some moment of the year to be feasible in the future, their yields. We have seen that in arable farms with cereals, and we have seen that in vineyards. So what we are trying to focus, and we have tried to work with authorities in Spain, but it's very difficult, is that maybe the policies regarding water for farming must be remade, because in some cases a lot of water is being used in irrigated farms, and maybe we should try to begin to change that and change some crops in irrigated areas and try to share that water with rain-fed farms, because water is going to be an important fact in the future. Yes, sure. And but it's not only a matter of water. What we have seen is that it's too a matter of heat waves and high temperatures. And in some cases, we won't be able to face high temperatures with more water. So we will have to change other things as the sowing date or the rotation of crops and so on.
Okay. Thank you, Vanessa, for answering all the questions. I think it is very clear your approach in the project, and I understand we have a lot of summary of best practices that can be used for farmers in all regions in Europe. Yeah. Now it's time to go for the next speaker. So Jonas, it's your turn. Thank you, Vanessa.
Thank you very much.
Thank you, Vanessa. Yeah, it's time to Enno Hull from the Technical University of Munich. It's going to present Climate Fits Forest project. Enno works as a researcher at the Chair of Forest Growth and Yield Science at the Technical University of Munich. He is responsible for the management and scientific exploitation of the Bavarian network of long-term yield trials. His main research is focused on the effect of drought on tree and stand dynamics and resilience. Enno was the coordinator of the Climate Fit Forest projects, which will be presented here. In 2015, Enno was awarded the Percy Staffs, John Bolton King, and Edgar Garfield Silvicultural Prize by the Institute of Royal Chartered Foresters in the United Kingdom. Since 2018, he is the coordinator of the 2020 project Care for Sea, entitled Carbon Smart Forestry Under Climate Change. Enno, thank you so much, and it's your turn.
Yes, thanks, Jonas, for the introduction. Can you hear me?
Yeah, perfect.
Okay. I'm honored to have the chance to share the project idea and project results of Climate Fit Forests with you. Climate Fit Forest was a FP7 project from 2012 to 2015, so it's some years ago that we finished the project. And I want to present some highlights of this project. And as you can see, it was a mobility project. So maybe in terms of carbon released by moving was not so good, but it's the intention of this IRSIS project, that means International Research Staff Exchange. That was,
could you share your presentation, please?
Isn't it shared?
I can't see it.
It should be shared. Wait a moment. Maybe I have to share it again. Can you see it now?
Yeah, perfect.
Perfectly well.
Okay, sorry for that. Okay, it was a exchange project between, and four countries were involved. It was Germany, Italy, Switzerland, and South Africa. And our motivation was similar to what Vanessa just reported about, that we wanted to look at adaptation and mitigation possibilities in forests to climate change. And we wanted to to understand and to enhance the knowledge about the reaction. But the problem in forests is that they are not so fast growing as agricultural crops. And to get an idea about, let's say, stress events or long-term trends, you need a lot of, or you have to put much effort into getting respective data. So our idea was to get a better insight into the carbon fluxes in forests and in forestry. And we had two focus areas, which is here on this slide called Work Package 1, which was focused on, oh, where's my mouse? On the question how carbon is sequestered by forests and forestry. And the second one, so this is the zinc question, and the other Work Package 2 was looking or focusing on the carbon emission by forest operations and forest management. So what is the effect of forestry on carbon release, as well as carbon release by risks or hazards like forest fires or bark beetle attacks and so on. And then we wanted to combine the results of these two work packages into somehow a toolbox and to provide it to the audience. And the main approach in our project was that we followed different gradients. So we, on the one hand side, we had an environmental gradient, meaning that we were looking at different sites. As we already heard today, that climate change is differently on different site conditions. So we had a gradient of different site conditions and of the intensity of climate change. Then we looked at different forest types, meaning that we were investigating plantations or monospecific stands, as well as mixed stands and very complex stands, high structured stands. And related to this, we had a gradient in different forest management types. And then we had the ambition to look at different scales, meaning that we were looking what is happening on the cell level, what is happening on the tree level, and what is happening on the stand level. And if you look at the part of carbon sink or carbon sequestration in forests, then you have to be aware that dynamics or that processes can happen on different levels. So, for example, you see here sketched how site conditions, if you look at the colored arrows at the top, how they trigger the tree and stand development, and you can refer to this reference here. This is a site condition, and maybe on the right hand side you have a better site condition, on the left hand side you have a not so good site condition. And then if site conditions change by climate change, then you will have a change in resource allocation. And this resource allocation can happen between organs, like between root and shoot, or it can happen between the distribution between trees of a stand, and then it can affect the stand level itself, like productivity or resilience and so on. And we try to trace different levels of the process or the link between site conditions, climate change, and tree and stand growth. And I want to present some examples what we did. So we mainly did research or pure research in this project, and one aspect deal with the root shoot allometry. You have to imagine that we caught trees, and if you caught tree, then you have the historic information about the tree growth, and you can relate it to climate time series as well. But if you core the stem and the root, and you calculate trajectories between shoot growth, you see it on the right-hand side on the x-axis, and the root growth, then you can see what strategies trees follow to allocate biomass, either in above ground biomass or in below ground biomass. And this is very important because this is site dependent, and you can reveal how the site conditions, for example, dry site conditions, or the trees on dry site conditions invest more into roots. And to have this allometric relation between stem growth and root growth helps to estimate the total biomass produced in trees and in stands, which is normally not so easy to access because you cannot dig out each root of a tree. A second topic that we dealt was that we looked at again below ground processes. We used the ectomycorrhizal communities as an indicator for drought stress, and for that reason we assessed different stands in South Africa and tried to first describe and systematically identify the taxa in these Pinus radiata plantations, and then we associated this with environmental variables like drought, soil chemical and physical characteristic, but also with the silvicultural management. Because if you apply silvicultural management, you usually alter the stand density, and this has an effect on the below ground processes. And then we looked we tried to investigate how climate change, let's say in terms of stress events, but also in terms of gradual long process, how it reacts on tree growth. And for this we installed several trials in Europe and in South Africa, and we equipped them with so-called dendrometer bands to get an idea about the growth. For example, here in Pinus radiata on the left-hand side, and another example was in eucalyptus, which are main species in South Africa and very relevant there. And then if you retrace the growth, then you have the possibility you can see it on the bottom left, that you can see the growth direction of a tree intra-annually. So we can directly relate the growth with the climate conditions. But you can also investigate it over several years, and you can see on the right-hand side how different site conditions from wet to dry sites influence the volume growth in these stands. And if you follow the same colors, if you establish plots in different aged stands, then you can create an artificial time series. And this is one method in forestry to get very quickly to an idea about the whole process of stand development over several decades. Another point was that we looked at size growth relationships as a measure for resource distribution and mode of competition. So this graph in the center of the presentation of the slide gives you an idea how the growth is distributed between trees of different sizes, and this can follow different lines, let's say, which goes from complete symmetric patterns. That means it does not depend on the tree size where growth is distributed, and this can go to 4 size asymmetric. That means big trees profit from their size and can allocate most of the resources to themselves. And this is very important because this relates to the possibility how you can treat this stance by silvicultural measures. And we did this, for example, in a very complex stance in the Southern Cape in South Africa, in a natural Afro-montane forest, which is very diverse. And we looked how this size growth relationship varies between tree species and how it varies over time. And you can see that there is a change over time, and this over time can also reflect a change in climate. And we looked how it changes depending on environmental conditions. And then we applied to aggregate our information different models like water balance models. You see on the left-hand side the type of soil vegetation atmosphere transfer model that incorporates soil information, plant information, and meteorological information to get an idea about the water balance of a site. And you can, we applied process-based growth models that also include this information about soil, plant, and meteorology, but also emulate the growth processes like transpiration and assimilation and so on. And by doing this, you can estimate or simulate how a climate change can affect growth of stands, of trees and stands. So for example, one study here revealed how on different sites the yield or the growth is reduced by applying different climate scenario, from a drier to a more wet scenario. And in the part of carbon emission, we initiated a very big literature review and created a bibliography of global carbon emission data from forest machinery in operations. And this is very important to get an idea about what amount of carbon is released by forest operations, because the forest operation systems vary so much globally, and depending on the machine type, depending on the terrain, and depending on the forest type and so on. And we compiled a huge database on information on carbon emission by forest machinery, which then can be used for optimizing the operation system. And on the same time, one group of us developed an integrated forest operations software. And we already heard today that transport is a main factor of carbon emission. And even in forestry, we have a huge amount of diesel consumption for harvesting and for timber transport. And the idea was to make use of this so-called controller area network, which is in communication system within the machine that controls or that sends communication messages between the engine and the engine stages. And you can use this data to get an idea about the fuel consumption. And if you can measure the fuel consumption in situ, then you can estimate what you can see on the right-hand side in a forest stand, where the fuel consumption is colored in different intensity, and you can identify where fuel consumption is high, where is it low, and you can relate this to the terrain characteristics, for example, and to the forest stand to again optimize the carbon, or to minimize the carbon emission by forestry. And we also had some economic questions or economic topics within our project, and you can see that the project was quite interdisciplinary. So we applied this portfolio theory to forest stands, and this portfolio theory combines on the one hand side the risk of a crop, for example, and the return. And if you or this Markov chain try to evaluate which asset is best in terms of return and risk reduction. And we did this for an enterprise in South Africa using Eucalyptus grandis, which is grown mostly for biomass production, and for Pinus patula, which is used for sawn timber. And they have different risks in terms of forest fire, for example, so in terms of pathogens, but they also have a different revenue return. And if you calculate this, depending also, or let's say also including climate change scenarios, then you can estimate the best share of these different crops in forest enterprises.
1 minute, Enno.
Yes, I'm at the end of my presentation. I just wanted to say that this was a specific, as I mentioned before, a specific funding scheme, and it's about people. So the knowledge was mainly gained by exchange of people. So we met a lot of people, and this is maybe an advantage compared to classical research projects, because much more people are involved in this type of project. And we were lucky to have a follow-up of this project, which is one is now running. It's called Care4C. It's again a Marie Sklodowska-Curie action, a so-called research and innovation staff exchange. And this year, we are currently in a grant preparation phase for the Skill for Action, which is a PhD program. And within this project, we can utilize the data we gathered in climate fit forests. And you can see that we very much enlarged our cooperation. So it's always growing. But that was the idea. So the idea of climate fit forest is going on to get more information about the interaction between climate change, and stand and tree growth. Okay, thanks very much.
Thanks, Enno. Before moving on to the questions, I'd like to ask Xavier Diaz of the Basque Center for Climate Change to turn off his camera. Xavier, could you be so kind as turn off your camera, please?
Okay. Thank you, Enno, for your excellent and detailed presentation on forestry growth and forestry stands growth a long time. We have time for one or as much 2 questions because we are running a little bit behind time. But
yeah, sorry for a long time.
No problem. We started already a little bit late. As I don't see any question in the chat, I would like to ask you one question myself. I see that you have mentioned that for getting the data to feed all these models and to learn more about tree growth in forest with regard to climate change, you have developed a network of long-term yield monitoring plots in Bavaria. We know here in NACER, for our experience, that maintaining this type of research plots is quite expensive. How do you get funding for this? Which data you collect from the stands, and how do you use the data for the Forest Service, for the people who is going to apply your results?
Okay, this is a long history in Bavaria, and maybe it's a very specific case, and maybe we are really lucky to have this. But the network of long-term experimental plots in Bavaria started already in 1870, and this was the time where all this, at least in German-speaking countries, where the research institutions in forestry were established. And since then, this network was enlarged and always maintained by the Forest Institute. And so we are lucky to have now the network maintained by two organizations, and it's the Bavarian Ministry of Forestry and the Technical University in Munich. And there is a regular funding of these plots. We have round about 1,000 plots, not only in Bavaria, but all over the world as well. And it's a quite huge effort to maintain all these plots. But we get money for this, and due to the fact that the Bavarian Ministry is also a partner of this project, it's let's say easy for us to get the connection between our data, the results of our data, and bringing it to forest practice, because we can also use the plots for training purposes.
Okay, very good. Just the last question then, under areas from NACER, which would be the best adaptation measures or adoption measures for forestry at different levels, from tree to stand or to landscape?
Yeah, this is very very complex question. I think the most convenient way is also Vanessa presented, is that you have somehow a diversification of your forests, because if you have different, let's say, resilient tree species, and let's say tree species that are very plastic in terms of the adaptability to site conditions. I think this is the best way to deal with climate change and stress events. So meaning species mixing.
Okay, thank you, Enno. We just have finished our time for your presentation. It has been a very detailed one, and I think we have a lot of ideas. And one of the persons in the audience, Vanessa, I asked for sharing your project publication or articles. Likely they are in the web page, but we would try to get Vanessa the web page address to later on. Okay, so we can move ahead to the next presentation. Jonas, please.
Yes, thank you, Enno. Could you close your presentation, please? We move on to the next talk that is entitled Regional Climate Change Scenarios Informing Impacts and Adaptation. José Manuel Gutiérrez is the person in charge of this presentation. He has been working as a research professor at the Spanish National Research Council since 2009, assigned to the Institute of Physics of Cantabria. His research focused on regional climate analysis, including the regional projection of climate change. He is coordinator of authors of the chapter Global and Regional Atlas of Climate Change for the 6th report of the Intergovernmental Panel of Climate Change. He's also a member of the Science Advisory Board of the International Initiative Cordex, and he's involved in the development of different components of Copernicus. José Manuel has published more than 150 papers, and he has been the principal investigator for 7 European projects, from the 6th framework program to Horizon 2020 and 5 national projects. José Manuel, please.
Hello, everybody. Can you hear me?
Yeah.
Okay.
Perfect.
I'll try to share my screen. And in case it doesn't work, can you see the screen?
No.
Let me try again. And if not,
Yeah, José Manuel, we can see your screen, your presentation.
can you see now? Okay,
Yeah,
because I can't. But that's fine. So can I go ahead?
Yeah, of course.
Okay. So first, thank you for inviting me to this networking workshop. The idea of my presentation is to give a very brief overview of the current state in regards to the production of regional climate projections, climate change scenarios, which is basic key information for informing impacts and adaptation studies. So I'll go. Can you see the new slide now?
Yes.
Okay, good. So I keep on going. So the production of climate change projections is an international activity which is coordinated by the coupled model or climate model intercomparison project, this CMIP acronym, which feeds a number of initiatives like the IPCC. So IPCC reports build on the projections developed in this CMIP initiative. And the idea there is that a number of groups in the previous CMIP 5, which ran through 2010 to 2013, a total of 29 groups participated with a total of over 60 models contributing to this projection activity. There is an ongoing one, is CMIP 6, is informing the next IPCC report, AR6, which will be published next year, but is still ongoing. There are a number of projections available, but not all of them. So the idea of those projections is that we know the radiative forcing, which is the sun is heating the Earth, and we have this problem with this greenhouse effect, which modulates this warming, this radiative forcing. So the black curve shows the radiative forcing in the historical period, with the increase, this trend in the past 4 or 5 decades. So we know what happened in black, but we don't know the future. So for the future, we have different possibilities. So we have a red scenario where high emissions are expected. We have a moderate and we have a low emission scenario. So the idea is that we can run models in the historical period and then project the evolution according to the different emission scenarios in the future. And this is a very complex computational process, which is good to know to understand the limitations, because at the end we have equations that we solve globally, considering a grid, considering a discretization of the globe, typically in cells or grid boxes of 100 kilometers or larger. So regional details are smoothened. And we use those models with the particular forcing, the historical, in a predefined period, in a historical period, for instance, 1980 to 2010, 30 years. And by running the model, we see the climate, the current climate, the historical climate. And we can do the same in the future, in the 21st century. For instance, in green is the end period, the 2070 till the end of the 21st century. So again, a 30 years period. So I can do the same simulation with a particular, in this case, is the high emission, the red curve. And what we get is the new climate, the climate in the future. If we take the difference of these two, what I get in the right is the climate change signal. So this is the key, the scientific basis behind those global or regional, as I will show later, global climate projections. But the idea is that instead of using a single model, this has to be done with a number of models. So on the left, you have all the models, key models contributing to the previous CMIP 5. So at the end, this warming for the end of the century is not a single one, but is as many, I have as many different warming projections as models. So at the end, what I need to do is to work with this multi-model data set. So a single model is not enough because in some cases you have a lower signal than in others. So you need to take in a way like the mean and the deviation, the uncertainty that you have in the projection. And that's not key for temperature because all models, as you can see here, produce very similar warming patterns in the future, but it's key for other variables where you can have mixed effects. So this is one of the take-home messages. We need multi-models. So what's the problem with this? That we have on the top the model space. This is the typical image with the typical resolution coming from a global model. So those models give you a number of variables in the center, which are required for impact models like humidities, winds, and so on. But the real world is more is more complex. So you have high resolution. In some cases, you need to work with local data for precise locations or with high resolution grids. And from the data set, you need to compute climate indexes, which in some cases depend on high thresholds, like, for instance, heat waves depend on temperature above 40 degrees, things like that. For applications in a number of fields, hydrology, energy, agriculture, you need calibrated information. So the picture on the top doesn't really help in doing that process. So we need to deal with two problems. The first is resolution, and the second is model biases, because in the model space, the model space is not the same as the real world. So for instance, in the Cantabria, in the northern coast in Spain, you see that the model does not provide any grid box, because those grid boxes are for land, only land. So in that case, we need to consider also oceanic grid boxes. So the situation is complex. So you need to deal with the different components from the model to provide regional information, and mixing ocean and land could be problematic. So there is a need of post-processing, of doing proper calculations to fit the particular study. And this is the focus of climate services, as I will describe later. So this problem of the resolution and model biases is solved with downscaling. And downscaling works under two approaches. The first one is dynamical downscaling. You have the global model on the top and the regional model on the bottom. So the idea is that to produce high resolution information, there are another initiative is similar to CMIP, but the name of this is Cordex. And what they do is they couple regional models running on a higher resolution, typically for Europe 10 kilometers resolution. And they coupled those regional models to the global ones to produce higher resolution information. So on the right, what you have is the orography, which is represented in the model. On the top is from a typical global model, and on the bottom is from a typical regional climate model. So you see that by this downscaling process, the orography and the regional effects can be captured properly. And this is the idea of this dynamical downscaling. There's another approach which works not on a higher resolution, but at a local scale. If you have observations for a particular point for a particular grid, you can calibrate either the global or the regional climate model projections by using statistical methods, which are called statistical downscaling methods, which take the raw model output, so the model signal, either global or regional, and calibrate against the local observations for a simultaneous period, typically a historical period. So if the model is biased in the way that your station may be in a valley location at the bottom of the valley, so even the regional climate model at a 10-kilometer resolution is not able to capture properly this high complex orography. So by this calibration, you can just fill this gap and just correct the model according to this difference with the observations. And that's very useful for many impact studies which run at a local scale. So what we have at the end is a very, very complex scenario in which global models are in rows. In this particular picture, this is the information available for Spain, for instance, which is very similar for Europe. And what you have in columns up to the dashed line, RCMs, are regional climate models, which are coupled to the global ones. So we have multiple regional climate models coupled with multiple global climate models in rows, in columns and rows, sorry, respectively. And similarly, we also have statistical downscaling models, which also work coupled to the global ones. So at the end, each single cell in this matrix is a plausible projection in the future. So we need to combine all of them, or at least to sample the more representative ones, given the high signal, low signal variability, in order to have a proper representation of the future climate projections at a regional scale. And again, this is a complex task which requires post-processing. Just picking at random one of those simulations would be misleading, would yield misadaptation, because you may choose the highest warming or the lowest warming, so you can cherry pick what is best suited for your expected impact, but that's not the proper way to go. So the idea is to sample this space. So this is how this information looks like, the current status in Spain. So on the left, you have for the network of stations from the Spanish Weather Service, AEMET, we selected those with high quality, with at least 3 decades with high resolution, with high quality data. And those are projections for a particular variable using this local station network. And on the right, you have the same, but for the regional climate models for Cordex at this 10-kilometer resolution. And you can see similarities and differences. So the spatial pattern is very similar, but on the left, you don't capture, for instance, the high mountains in the Picos de Europa, in the north of Spain, or in the Pyrenees, where the temperature, this is a temperature index, by the way, the temperature is colder than in the rest of the country. But since you don't have stations there, you cannot properly capture this particular issue. So any particular application requires a careful study on which from the information available is better suited for doing reaching the goals, the particular goals. And you can go even further and use statistical interpolation techniques To get from this 10 kilometer, this is the region where I live in Cantabria. So it's 100 by 100 kilometers. And what you see with the boxes on the left is the 10 kilometers resolution provided by Cordex, for instance. So starting from there, you can get to the final resolution, the 1 kilometer resolution on the right, by just geostatistical interpolation, taking into account elevation, orientation, convexity, things like that. So this is the final step, which is sometimes applied. So you can get from the figure on the left bottom hand side, which is the Cordex, to say the 10 kilometer resolution. To the right hand side is the interpolated 1 kilometer resolution. This is precipitation, or this is temperature again, sorry. The high elevation, the mountains, and so on. So I think I've gone very quickly, but this same idea of using high-res regional climate projections from Cordex, for instance, and interpolating with geostatistical techniques have been used in a number of regions in Spain. This is, for instance, the Basque Country. The pilot study was in Cantabria, the region that they first saw. And this is the neighbor region, the Basque Country, where Naker is based, and the area of influence. And what you have there is the network of stations available on the bottom left, and on the right-hand side, the corresponding climatology, the corresponding 1 kilometer grid, where the future climate projections are also interpolated. So in some regions, we have high-res 1 kilometer information, and in others, the highest resolution available is just 10 kilometers from Cordex. But overall, what is needed is to work on a coordinated way under this climate services umbrella, which consider model data. This is what I have tried to explain today. The data which is available for regional studies, regional climate projection data, is very complex. Is a number of approaches with different assumptions and different limitations behind. So you need to work together with people understanding this data, but not alone, because any application have key requirements. It's not the same working with hydrology or with the forestry examples before. Each application, each impact sector or adaptation study has particular requirements. So the idea is to work together, modelers, climate modelers, and impact modelers, with the help of web technology. So there are a number of tools which facilitate a lot this process of choosing the proper data available for a particular region. So this post-processing work can be done very efficiently. In some cases today, we have Copernicus at the European level helping us to access data and even to post-process data. We have in Spain, the Spanish National Adaptation Program with a number of tools which also allow you to do this work. You have open software. So there is a big variety of tools which can be used nowadays to do this. And the idea is that at the end, we need to develop customized solutions. So we need to address the particular problems for a particular sector, like agriculture, for instance, or water scarcity, and focus on the particular targets and develop the whole chain, the whole process from model data, going through the user requirements, using the proper tools to get customized solutions ready to use, so users do not need to repeat this time-consuming and specialized process again, so they can get the precise information that they need for their applications. I think that's all. So we have time for questions, I hope. Hello?
Okay, thank you. Yeah, thank you, Jose Manuel, for your introduction to the so complex subject of climate prediction for the future. I think it was really clear. We have time, as you say, for a couple of questions. If I don't get any in the chat, maybe I can ask you one question. What do you think is the future of climate prediction? Is artificial intelligence or work like, I don't know, like machine learning or this type of technologies can help to do your work, or is something that is you already have like a very well set up methodology and you are going to be working with that methodology in the future?
No, machine learning helps in that. So it's an active field with many potential applications, but the solution is not a particular tool. The solution requires this co-development process. So requires running a specific project oriented to a particular community for a particular use. So even agriculture is very wide topic. So it's not the same. So there are different objectives under the same topic. So the idea is to join together teams of climate experts and impact experts and develop tools which take into account the good practices. Because it's as I mentioned, it's a complex field, and it is almost impossible that a particular user or a particular group can do the whole chain alone. So at the end, there are a number of cases where projects are run using the best that they could. So picking models that they have at hand, or picking alternatives for post-processing that were easy for them to do, but not the best one. So there are a number of good practices already in place. So our group works on this regional climate projection activity, but we need to co-develop the tools with impact sectors under this framework of climate services. So the future is this team up activity, developing customized solutions for particular communities. So there is no magic tool which would allow end users or impact studies to do their job automatically. This does not exist. So there are tools which facilitate post-processing, but there is no magic tool which can do the whole chain. And there would be an increase of funding for those activities. There is already a lot of funding for climate services. So different calls under this Copernicus, climate services for Europe, but also in Horizon Europe and H2020. So the future to me is to focus on particular communities and develop the projects with very clear goals, objectives, developing tools ready to use for users.
Okay. Yes, very clear your answer. So I guess there is no one solution for everyone, and one has to do like a specific work with partners to just get results. And just the last question. Let's see, I have one question here. In Spain, can you provide the forecasted data for the next 20 years to introduce them into agronomic models?
Yeah, so those regional climate projections that I described do precisely that. So you can get daily data, day by day. So you have to understand the data in the climate change context. So every day in the future is not a prediction, it's a projection. So you need to run the impact model with the time series for 20 years, for instance, and see how things will change also in the impact model output. But you don't have a single time series for the future. As I try to explain, you have hundreds of plausible time series for the future, and you need to combine those in a proper way. So you cannot pick just one of them. You need to analyze for your particular region and problem. This ensemble of 100 simulations may be switchable. You may run your impact models 100 times. So that would be perfect, but maybe not. Maybe the impact model is too complex to be run 100 times, for instance, in hydraulic or hydrological processes. So then you would need to figure out which 2, 3, 5, 10 simulations, time series, out of this big ensemble are the ones that you need to run to do a proper adaptation or a proper impact modeling exercise. So the data is there. You have plenty of data, time series for the near future, mid-term future, the end of the century, gridded, local, but it is not trivial which information you should use for a particular project. That's the real problem.
Mm-hmm. Okay. Thank you again. Yeah, no, thank you again, Jose Manuel. It was again clear that one has to know exactly what one wants for those predictions or projections for the future. I think, Jonas, that now we are in time for the coffee, no? Because
yeah.
Okay,
yeah.
okay. Thank you, Jose Manuel.
Thanks, Gerardo. Thanks, Jose Manuel. Yeah, we are 15 minutes late, so we will take a 10-minute break to stretch our legs, and we will come back at 11:50, for example. Yes, at 11:50 with Borut Berce from the Agricultural Institute of Slovenia with the Links for Soils project. So at 11:50, in 10 minutes, we will come back again. Please do not close your sessions. See you in 10 minutes.